Assalamu alaikum dear students. We will be learning about the activity 12.2 which is mentioned on your workbook page number 173, and it asks about, is a larger magnet always stronger than a smaller magnet? So let me be very clear about it. You cannot prove this thing unless or until you have hands-on experience with magnets in the science lab. But since some of you are not coming and it was not possible for the ones who were absent today, it was not possible for you to conduct this activity in the lab. We will be taking, I will be taking all of you together to the science lab, and we will be doing it collectively in the lab, where we will be examining the effect of larger magnet and the effect of smaller magnet over the paper clips. Now you're going to demonstrate this activity in any way you would want to. There is no obligation, there's no any set pattern for you to go forward towards an activity. You can take on any move in order to prove the strength of a magnet. So basically you have to prove that the hypothesis is that is a larger magnet always stronger than a smaller magnet. And what is the aim of this activity? Like, you have to plan, you have to carry out an investigation to find out whether a larger magnet is always stronger than a smaller magnet. So this is our hypothesis. We have to see that if larger magnets are always stronger than the smaller magnets, and the operators that they are going to give us is a small bar magnet, a large bar magnet, the small neodymium rare earth magnet, and a box of paper clips. Now you will be provided with these three magnets of different sizes in a box of paper clips. Now, how are you going to find out if a larger magnet is always stronger than a smaller magnet? Now, you have to discuss it with your group members once you're in the science lab. But let me be very honest and clear with you. The diagram on your screen is clearly telling you that what you've got to do. Now, there are two magnets which are equal in sizes. They are like M1 and M2. So the smaller bar magnet and the other one, which is the small neodymium rare earth magnet, they both are of the same size. And the third magnet is obviously the larger magnet. So the human, normal human being would perceive that, okay, fine, the larger bar magnet would obviously, or the larger, that's not a bar magnet, that's a U-shaped magnet. But I am, having this picture because, unfortunately, I couldn't find a better picture, having a, paper clips attached and the strength of a magnet worksheet for my screen recording. I found this better image, but we have to use a bar magnet, in the lab once we are going to have a hands-on experience with this activity. So what you're going to do is you have to you have to carry out the experiment in which you are going to attach paper clips with your bar magnet, and then you have to count how many number of magnets that you you can attach. So you'll find that out that both the smaller magnets, of equal sizes, they, one of them had, if you count the number of paper of clips, I think one had, we count 1, 2, and one had 2, and M2, which was apparently equal in size to the first one, and it had 1, 2, 3 paper clips attached. However, the bigger one is having 1, 2, 3, 4, 5, 6 paper clips attached. So look at these three magnets above. M1 and M2 are the same size, and the magnets show how many paper clips they can hold. So it's like all are the magnets M1 and M2 are the same strength? No, because obviously you can see that they are of the same size, and the human mind would obviously perceive that obviously they are of the same size, so they would have the same strength. But actually that's not the case, and you can see that M1 is having 2 paper clips, however M2 is having 3 paper clips. So obviously this means that though they have the same size, they don't have the same strength. So the size doesn't really matter. But if there is a conspicuous increase in size, like let's say you've got M3 and it's such a big magnet, and you can see that it is holding 6 number of paper clips. So yes, question number 2 says that which magnet, M1 or M2, is the strongest? So obviously M2 is the strongest. Among M1 and M2, M2 is the strongest. But among, if we talk about all three of them, M1, M2 and M3, so M3 is the strongest magnet, then M2 is the strongest magnet, the less strong as compared to M3, and M1 is the least strong, among these three. So the three part number A is, if we are testing the strength of a magnet to do all paper clips have to be of the same size. So yes, I mean, in order to do a fair test, you have to keep all the variables the same. You don't have to change any particular variable, because if you're going to do, then there is going to be an anomaly in the test, or there is an aberration, or you can say that your results would not be valid, because in a fair test you have to change only one variable at one time. In this case, we are choosing different size of the magnet, and this is what we are varying, and we are also checking that if same size matters. You can see that the same size matters because even though M1 and M2 are of the same size, but M2 is the strongest. So then I've given the reason, just before, a second. Question number 4 is, which of the three magnets is the strongest? So obviously M3 is the strongest, and M2 and M1 are less strong, but among M1 and M2 is more strong as compared to M1, because it can hold 3 paper clips. Now, keeping this concept in your mind, you have to attempt activity 12.2, and in activity 12.1, you also have to attempt activity 12.1, in which you have got different materials, and it is basically descriptive. If you'll open your book, you're able to attempt 12.1, but 12.2 is a little bit tricky. So the conclusion is that yes, the size does not matter. It doesn't have to be that the smaller magnets would attract less number of paper clips and the bigger magnets would attract less number of paper clips. So you can say that if there is a conspicuous increase in size of the magnet, so yes, the bigger magnet would attract more number of paper clips, but if they are of the same size, so we cannot predict that they will attract equal number of paper clips. There could be a possibility that they can go and attract, one can attract more and the other can attract less. So the conclusion is that the size really doesn't matter unless or until it's a conspicuous one. I hope these words would have made sense to you, or if they did not make any sense to you, you're very welcome to contact me back on the WhatsApp and